Welcome to the Deep Dive, where we unpack the insights that truly matter. Today, we're diving into something that's, well, everywhere: artificial intelligence. And specifically, those incredibly powerful large language models, LLMs, things like GPT-4, Llama 3, Claude 3, their abilities with language are just, they're stunning. But, despite all that power, there are some pretty big hurdles popping up, especially for businesses wanting to actually use them widely. I mean, think about it. These giant models, they cost a fortune to run, need serious hardware, and the speed, the latency, it's often just too slow for real-time stuff. Plus, there are these growing worries, and they're totally valid, about data privacy, keeping sensitive business information safe.
Exactly. And that's really where our deep dive kicks off today. Because while the big LLMs get all the press, there's this other thing emerging, a really strategic answer to these problems: small language models, SLMs. Now, these are models with, say, a few million, maybe up to hundreds of millions of parameters. It's a totally different scale compared to the billions, sometimes trillions we see in the big guys. So our mission today really is to explore how these SLMs are reshaping AI in the enterprise. We'll dig into the tech advantages, look at some actual real-world examples, and see how they actually stack up against the LLMs. The idea is to give you a kind of shortcut, right, to understand why SLMs are becoming so critical for businesses, large and small. Often, they're just the smarter play.
Yeah, exactly. Think of this as a journey into, well, practical enterprise AI, focused on efficiency, privacy, and, crucially, scalability. As we unpack this, I think we'll see why small might just be the new smart when it comes to business AI.
Okay, let's dig in. So first things first, what are SLMs really? Are they just like scaled down LLMs, or is there more to it? From what we've seen, the basic architecture, it's pretty similar, right? You've still got transformers, attention mechanisms, contextual encoding, all that core stuff that helps them understand language. But the big difference, the headline, is the number of parameters. It's drastically lower. LLMs are in the hundreds of billions, maybe trillions. SLMs, we're talking maybe 1 million up to, say, a billion. Though for businesses, the sweet spot seems to be around 7 million to 7 billion parameters.
That's spot on. And it's not just theoretical. We're seeing some really impressive SLMs out there already, like Microsoft's Phi 3, it's got about 3.8 billion parameters. But benchmarks show it performing like models 10 times bigger, which is pretty remarkable.
Wow. Then there's Google Gemma. That comes in 2 billion and 7 billion parameter versions. It's open source and really tuned for running on edge devices like phones or sensors.
Okay.
Mistral 7B is another big one, known for great performance. And it has a business-friendly license, which is important. And if you need something really small, like for a mobile app, there's Tiny Llama. Only 1.1 billion parameters, but trained on a massive 3 trillion tokens of data. And what's really fascinating here, it kind of flips the script on that bigger is always better idea in AI. There was this Microsoft research paper back in April 2024, the Phi 3 technical report. They showed Phi 3 Mini, the 3.8 billion one, actually outperforming bigger models like Llama 2.7b on things like reasoning and reading comprehension.
Really? Outperforming bigger ones?
Yeah, it suggests that, smart design, good data curation, that might matter more than just raw size sometimes. And that's the key insight for businesses thinking about AI today.
That idea, that size isn't everything, it's huge.
Yeah.
So that brings us to the really crucial part for businesses. Why should they care? What are the actual strategic advantages here?
Okay, the first big one, and it hits the bottom line directly, is computational efficiency and cost reduction. Simply put, SLMs need way fewer resources.
Okay.
And that means, well, concrete benefits, like up to 10 times faster responses, even on regular CPUs, not fancy GPUs. Suddenly, real-time applications are actually feasible without breaking the bank on hardware.
10 times faster. Wow.
Plus, they use much less power, perfect for devices out in the field, IoT sensors, things like that, where energy is limited. And obviously, lower resource needs mean lower running costs, less reliance on expensive cloud servers or those high-end GPUs.
Right.
There was a Stanford HAI analysis, I think from 2023. It found running a 7 billion parameter model could cost up to 90% less than a 70 billion one for inference.
90% less.
Yeah, 90% less, often with only a tiny drop in accuracy for specific focused tasks.
90%. That could totally change the ROI calculation for so many companies. But, okay, running things locally sounds great for cost, but what about privacy? Especially with sensitive business data, is that where SLMs really shine?
Absolutely. That's probably one of their strongest suits, privacy and data sovereignty, because you can run them locally, either on your own servers, on-premise, or even directly on an employee's laptop or phone.
Right.
That means your sensitive data. It never has to leave your control. It doesn't get sent off to some third-party cloud API.
Right.
This is massive for compliance, things like GDPR, HIPAA, CCPA. It makes meeting those rules much easier.
Okay, that makes sense.
And just generally, it drastically cuts the risk of confidential information getting leaked or exposed. Think about it. It's like having a super smart assistant who works entirely offline, never uploads anything. We saw a great example with Banco Santander. They used an SLM for analyzing internal legal contracts. Why? Specifically so those confidential documents never had to be sent to an external service. That came right out of their tech report in 2024.
That Santander case really hits home the control aspect.
Yeah.
Okay, so cost is down, privacy is up, but what about making the AI understand your specific business, your jargon, your internal processes? How easy is that with SLMs?
That's another key area. Personalization and accessible fine-tuning. It's much, much easier and cheaper to adapt an SLM to your specific world. You don't need massive data sets either. Sometimes fewer than, say, 10,000 examples can be enough.
Really? Just 10,000?
Yeah, to get it tuned into your technical terms, your internal workflows, whatever makes your business unique. And they work really well with this technique called RAG Retrieval Augmented Generation.
Right.
Yeah, think of it like giving the SLM access to a specific, up-to-date library like your company's internal knowledge base.
Yeah.
So before it answers, it checks that library for the latest, most relevant context. It makes the answers much more precise.
Ah, okay, so it's not just guessing, it's looking things up.
Exactly. It grounds the model in specific facts. There was a paper from the University of Washington in 2023. They fine-tuned a Mistral 7B model with only 5,000 medical examples. And it actually outperformed GPT-4 on certain specific medical tasks, not because it was smarter overall, but because it was highly specialized.
Wow. Specialization beats generalization in that case.
For specific tasks, absolutely.
Okay, specialization makes sense. And finally, you mentioned edge devices earlier. Let's talk scalability and edge deployment. This goes beyond just the data center, right?
Totally. This is where SLMs open up possibilities that are just, well, impossible for LLMs. They can run on devices with limited resources. Your phone, a tablet, sensors in a factory, embedded systems in cars or logistics equipment.
So AI directly on the factory floor or in a delivery truck.
Precisely. Which also makes them ideal for situations where you don't have a constant internet connection or where sending data back and forth isn't practical. Think remote locations or maybe sensitive environments. Apple gave a great example at WWDC 2024. They talked about integrating compressed SLMs right into iOS 18 for on-device processing, meaning things like text summarization could happen right on your iPhone, no internet needed. That's true edge AI.
Okay, these advantages aren't just theory, they're actually making a difference now. Let's look at some of those real-world use cases. Where are businesses actually seeing results with SLMs? These are the aha moments, right?
Absolutely. The results are starting to pile up across different industries. It's pretty compelling. Take healthcare. There's a clinical assistant using Phi-3 combined with that array technique we mentioned. It cut documentation time for doctor's notes by 40%. That's huge in terms of freeing up clinician time.
40%, okay.
In banking, Mistral 7B was used to classify customer support tickets. It hit 92% precision. The old system, based on static rules, only 85%. So better customer service, more efficiency. In retail, think about an in-store chatbot on a mobile device. One, powered by Gemma to be, managed to resolve 70% of customer questions without needing a human staff member.
70% handled automatically.
Yeah. And manufacturing. A predictive maintenance system using Tiny Llama, linked up with IoT sensors. It achieved 88% accuracy in spotting potential equipment failures early. Imagine the savings on avoiding downtime and major repairs.
You're failing.
And even in the legal field, Phi-3 Mini is being used for automatic contract summaries. The estimate was it saved lawyers about 15 hours per week each.
15 hours per lawyer per week.
Yeah. So these aren't small tweaks. These are significant operational gains.
Those examples are really powerful. It shows SLMs aren't just toys, they're solving real business problems. So this leads to the obvious comparison question. Are SLMs just like weaker LLMs, or should we think of them as different tools entirely? Let's compare them head to head.
It's a really important distinction. And no, they're not just weaker, they're different, suited for different jobs. MIT Sloan Review actually did a good breakdown on this earlier in 2024. Let's walk through the key points. First, size, obviously. SLMs, 1 million to maybe 7 billion parameters. LLMs, 100 billion up to a trillion, or even more. Big difference.
Right.
Then hardware. SLMs can often run on standard CPUs, regular consumer GPUs, or edge devices. LLMs, they need serious server GPUs, expensive cloud setups,
Okay, hardware's a big one.
latency, or speed. SLMs can get under 100 milliseconds on a CPU, great for real-time interaction. LLMs in the cloud, you're typically looking at 500 milliseconds up to maybe 2 seconds, much slower.
Noticeably slower for users.
Cost. This is huge. Per million tokens processed. SLMs might cost, say, $0 to $1. LLMs, easily $10 to $100, sometimes more. Orders of magnitude difference.
Wow.
Privacy. We touched on this. SLMs enable on-premise processing, full data control. With LLMs, your privacy depends heavily on your cloud provider's policies.
More inherent control with SLMs.
Personalization. Fine-tuning an SLM is relatively easy and affordable. Customizing a massive LLM, that's complex and very expensive.
Right.
And finally, creativity versus focus. LLMs are amazing at general knowledge, creative writing, broad tasks. But they can also hallucinate or make things up. SLMs are more focused on their trained domain, less broadly creative perhaps, but often more accurate and reliable for specific tasks. So you see, it's not about one being universally better. It really forces you to ask, what do I actually need this AI to do for this specific task? SLMs aren't a step down. There is strategic evolution towards precision and efficiency for many, many business needs.
That comparison really clarifies things. It's about picking the right tool for the job, not just the biggest hammer. But like any technology, especially newer ones, it can't be perfect. What are the hurdles? What challenges do businesses face when adopting SLMs?
Yeah, it's important to be realistic. There are definitely challenges still. One is complex reasoning. For tasks needing multiple logical steps or really deep, multifaceted thinking, SLMs often still need help. They might rely on RAG or more complex agent setups to handle that. They don't inherently have that broad reasoning power of the giants.
Okay, so multi-step problems can still be tricky.
Right. Another issue is standardized evaluation. We have lots of academic benchmarks, but fewer that are really tailored to specific enterprise contexts. It can be hard for a business to know objectively which SLM performs best for their specific workflow, not just on a generic test.
Comparing apples to apples is hard.
Exactly. Then there's tooling maturity. The whole ecosystem around deploying, monitoring, managing SLMs, what we call MLOps, it's still developing. It's not quite as mature or comprehensive as the tools built up around the big LLMs from major cloud providers yet.
So the support infrastructure is still catching up.
It is. And related to that is robustness and control. There's maybe been less focus on the breadth of testing and building control mechanisms specifically for SLMs compared to the huge investments in LLMs. Making sure they perform reliably and consistently in all sorts of real-world production scenarios can take significant internal effort right now.
Those are definitely important hurdles to be aware of. But you mentioned things are moving fast. So looking ahead, say the next couple of years, 2025 to 2027 maybe, what's coming down the pipe for SLMs?
Oh, the pace is incredible. We're expecting big leaps pretty soon. First, multimodal SLMs. We're already seeing this start with things like Microsoft's Phi-3 vision. This means SLMs that can understand and process not just text, but also images, maybe even voice, all within that smaller footprint.
So SLMs that can see or hear?
Basically, yeah, integrating different types of data. Next up, look for autonomous SLMs. Think lightweight AI agents. They could potentially handle routine workflows end-to-end, making decisions and taking actions without needing a human in the loop for every step.
More automation potential.
Definitely. We're also likely to see more federated SLMs. This is a clever way for multiple organizations to train a model together, pooling their knowledge without actually sharing their raw, sensitive data. Great for privacy-preserving collaboration.
Interesting. Collaborative training without data sharing.
Exactly. And finally, specialized hardware. We're seeing chip manufacturers like Grok, Halo, Intel with their NPUs. Neural processing units.
Yeah.
Basically, chips designed specifically to run AI tasks, particularly smaller models, much faster and more efficiently. This specialized hardware will make SLMs even more performant and accessible.
Wow. So multimodal, autonomous, federated, and specialized hardware. Lots happening. Okay, let's bring this home. For you, the listener, trying to figure out how this applies to your organization, what are some concrete strategic steps you can take?
All right, let's get practical. First, audit your needs. Seriously, look at your processes. Do you really need a giant general-purpose LLM for everything? Identify tasks where speed, cost, privacy, and specific knowledge are crucial. Those are your prime candidates for SLMs. Ask, what problem am I actually solving?
Good starting point. Don't assume LLM is the only answer.
Exactly. Second, Pilot open source SLMs. Don't be afraid to experiment. Grab models like Gemma, Phi3, Mistral. Many are free, well-documented, have business-friendly licenses. Set up a small pilot project. See what they can do.
Get your hands dirty.
Precisely. Third, invest in fine-tuning. A generic, off-the-shelf SLM is okay, but the real magic happens when you adapt it to your data, your domain. That specialization is where you'll see the biggest performance gains and differentiation.
Customize it.
Fourth, consider adopt a hybrid architecture. This is probably the most realistic approach for many. Use SLMs for, say, 80% of the routine, specific tasks where they excel. Keep them local, keep them fast. Then, reserve the big, expensive LLMs for those truly complex, creative, or broad knowledge tasks where they're genuinely needed.
Right tool for the right job, maybe using both.
Absolutely. And finally, number 5, establish AI governance. Right from the start. Put policies in place for how you'll manage these models, ensure ethics, audit performance, monitor them over time. Do this early, regardless of model size.
That's really solid, actionable advice. This whole deep dive, it really underscores that SLMs aren't just smaller, cheaper LLMs. They represent a strategic shift, right, towards efficiency, yes, but also towards specialization, control, technological sovereignty for businesses. It's about being smart with AI, not just using the biggest tool available.
I think that's exactly it. That old idea of more is always better is really being challenged. We're moving towards just right in the right place. And SLMs are proving, in real-world business settings, that a focused, well-trained, context-aware small model can genuinely outperform a huge generic one for the specific job it needs to do.
And the really exciting part, I think, is how this democratizes powerful AI. It means businesses of all sizes, not just the tech giants, can leverage high-impact AI, SMEs, larger corporations. They can do it without massive budgets, without giving up control over their data, without sacrificing speed or privacy. You know, in a world that increasingly values efficiency, agility, sustainability, control, SLMs really do seem to offer that perfect balance of power and pragmatism.
Well said. So maybe the final thought to leave everyone with is this. If the best tool for your specific job isn't necessarily the biggest or the most expensive one anymore, how might that change your fundamental approach to innovation, to problem solving within your own organization? Something to think about.